Coaching center. So today I'm going to explain you 11th standard physics first chapter, that is physical work part 2. In last video I explained the basic concepts, the basic things about physics. So now let's learn some more things that we about in the physical world. So in last video I explained you about the fundamental force in nature, that I explained the Newton law of motion and law of motion. So here they have given some link between technology and physics. So what is the link between technology and physics? See, technology, new steam engine was found, but that is running on the thermodynamics, on the law of thermodynamics that is running. So that is thermodynamics that belongs to the physics. So on this it is running, we can say, and many more reactions are there in this page. You can see many more. The technology like computers, it is running on the digital logic of the physics, and the radio and television, that is running with the generation electromagnetic waves, sound waves, wavelength on the in the physics. On that it is learning. And let's learn some fundamental forces in nature. Fundamental forces. Let's learn more about fundamental forces in nature. So the force due to pressure of fluid, or the force due to surface tension in the liquid, and many more so on, are the fundamental forces that we, or the force we learn. And there are the forces involved in the magnetic bodies, in the magnet, nuclear, proton, neutron, electron. Many more are there we learn in the atoms chapter. And also a great insight in 20th century, more scientists were there and they have found the new things. In the 12th century there were more scientists, in the 20th century there were more scientists, more new things they have found in the physics. And some of them are electroforce between the charges, and it runs in the principle, means the law that it runs is derived, and there are some fundamental forces, and there are some independent forces, and there are some fundamental, means they have they run in their surroundings, or in their rules. It means it has some stoppage in that it runs, and some many more are there. So here you can see about Albert Einstein we are seeing. And next is gravitation force. Gravitation force is the force of the mutual that attracts the object towards it. So every object in the universe is due to gravitation force, and all the objects on the earth, for example, earth particles, moon, satellite, and many other run moon of the motion of the bodies falling to the earth. It plays the key role. It is like a key role to the universe, such as formation, stars, galaxy. Many more are there. They all run on gravitation force only. The earth gravity attracts the due to earth gravity, they all run, means it is attracted by the earth gravity. And next is electromagnetic force, the force between charged particles. Two charged particles, the force between the two charges, whether it may be neutron, proton, whether it may be any charges, the force between the two charges is called as electromagnetic. And the force is given by the Coulomb's law. This is said, we understand this by the Coulomb's law. You will learn about that also. And charges in the motion, magnetic field you have, and magnetic effect you have learned in your 10th standard. And gravitation force, electromagnetic force, many other force are there, and it is 10 to the 13 times of gravitation force between them. So it is electromagnetic force is 10 to the 36 times between the gravitation force. And matter, as we know, consists of matter consists of electron, proton, elements it consists, and electromagnetic force is also much stronger than the gravitation force. Electromagnetic force is so stronger than gravitation force. And also, and this phenomena of atomic and molecular scales, as well as, and electromagnetic force is the governance structure of atoms and molecules, friction, tension, normal force, spring force. Many forces are there, and friction is the opposition of force between two objects, and many more things. Electromagnetic force are there. Normal force, the normal force, simply giving force. And gravity is always attractive, as you know, gravity is attractive, while electromagnetic force is attractive of two elements or two components, anything we can call like that. And another way of putting it is the mass comes in the mass also we can put. And but the charges come into two ways, as you know, negative and positive charges are there. You have learnt in your lower classes. And matter is mostly neutral. Sometimes it is neutral, means it does not become positive, negative, means it does not have 10 numbers, it will be 0. And thus the electric force is largely 0, and gravitational force, terrestrial phenomena, electric force manifests itself, and lightnings that comes from the atom's force, like that only it is going on. And here we are learning some more strong nuclear force and weak nuclear force. So first still is there the electromagnetic force. So let's see it is, if we reflect a light, enormous strength of the electromagnetic force compared to gravity is evident. The enormous, when we enormous strength is it has, when we see in daily life, when you put a force, gravity, it has very much force. See, if you are standing here, means the earth has more gravity. See, the cars, bikes, whatever it is standing on the earth, it all is due to gravity. Then we can say that gravity has more power. It is strength. It has more strength, we can say. When we hold a book in our hand, we balance at the gravitation force. Due to gravitation force of the earth only, we will balance that book. Otherwise, we can't balance. If you see in space, they can't be, due to no gravitation in space, the books, or they can't hold a cup also, or a small object also they can't hold, because of no gravitation. They will be only flying, you have seen, because of no gravitation. So gravitation is the thing they are explaining here. And the surface of contact is there, our hands and the book, there is a surface of contact between there. And due to that contact, because our body is standing due to gravitation, because of that only the book is also standing in our hand. And hand of is the strongest thing, it became weight. So it has strongest weight, circumference, and due to that we it is our hand is very good weight. So by that weight we can hold that book, and due to gravitation force we are standing here, they're telling. And strong nuclear force, so force binds proton and neutron in the nucleus. It is an evidence that without attractive force, it has proton and neutron. And this attractive force of the gravity negligible, since from force of gravity is negligible when it compared to electric force, current force. When we compare it, it is negligible, we neglect the force. And the fundamental force, about 100 times of the fundamental force is 100 times more than the electromagnetic force in strength. In strength, it is more strength. The fundamental force is more strength. And also it is the charge indentive, and it acts equally between proton and a proton. It acts equally between proton and proton, and between neutron and neutron, and between proton and neutron. It acts neutral, means it acts very much goodly. The strong nuclear force, or the fundamental force, we can say. And electron, it must be noted, does not experience. So like this only it is strong, they are saying. And however indicates that proton and neutron are built out of still more elementary constants called as quarks. The proton and neutron are built with more elementary constants, constituents, that is called as, we call it as quarks. So weak nuclear power. So the weak nuclear power appears to be certain nucleus process, such as p decay of nucleus. In this decay, the nucleus emits the electron, an uncharged particle. It has an uncharged particle called neutrino or neutron. Now we call neutron. Neutrino, it has uncharged particle called neutron. The neutrino. The weak nuclear force is not as weak as gravitational force. So the nuclear force is not weak as gravitational force. If gravitational force is also weak, but the nuclear force is not that much weak that it is more weak than the gravitational force. It is not like that. It has certain amount of force, but it is little bit weak, they are saying. the nuclear, strong nuclear and the electromagnetic force, but it is much weaker. So it is not less weaker than gravitation force, but it is much weaker than the strong nuclear force. Than the strong nuclear force, with the nuclear than the strong nuclear force, the weak nuclear force is much weaker. They are saying. So next towards the unification of forces. So here some gravitation force. Their strength is, they have given here 10 to the power minus 39. It has infinitive ranges. It has infinitive ranges. And towards unification of forces. So spheroids and domains. Newton and unifit terrestrial and the celestial domains are the under a common law of gravitation. It comes, and the experimental discoveries of Ostrander Faraday show the electric and magnetic phenomena in general. More things they are saying about the scientists who found the new things, and but this did not did the physicists from zealous pursuing the goal of unification of force. Means unification is making it as one, or unification of force. So the electromagnetic and the weak nuclear force, electro-weak force it also called as, and also it cannot be explained here, we cannot explain it here easily. And many more things it happens, and summary in 10.1.4 they are saying that some of the millstone of progress towards unification of force in nature. Towards the unification of force they have done many experiments they have done. So nature of physical laws. So what is laws? Physicists explore that universe, their investigation, the size, what they have did the investigation on that atom or on that law, they all give the information about that. In the physical phenomena governed by the different forces, several quantities are there. There are several forces. It should have quantity, physical quantity. However, they should have constant in time. Means it should remain constant in time. The time should be in constant. That means when they does experiment, that constant time they should be written when like that. And they are conserved quantitative in nature. They are should be conserved in nature. Means we can show that, or we can explain you for like this we are saying now. And these are conservation of principle, means saving it principle or the laws for the your for next future generation. And many more things. For example, they have given the gravity, kinetic energy of the object, potential energy, many more things that have found in the these days. They done the experiment and they have found about that they are telling. And these are the progress in the unification. These are the progress in unification. The terrestrial showed that the laws of motion, laws of gravitation apply both that. I mean the laws of motion and laws of gravitation both apply the domain. The Isaac Newton said that like that only they did. And here here in this page they have given some of the examples about the physical laws. And this law is conservation force should be confused with the general law of conservation of mass. So conservation of energy you have learned in your lower classes about conservation of energy. The concept of energy is central to physics, and expression for energy can be written for every physical system. So in every physical system, the energy or the thing they are using, it should be written. They are selling whether it may be electric energy, mechanical energy, heat energy, or any energy they conduct, it should be written. So in the following object example, if you includes the effect of air resistance during the fall, when you are falling from the sky, or when you falling, when you scuba diving, when you do the force you fall, the air how to say that. And the mechanical energy is obviously not conserved. So mechanical energy we cannot conserve, but the other energy like solar energy and the other energy we can conserve, and we can save it for we can use it. They are explaining about potential energy, more things, heat, sound energy, and the law of conservation of energy, storing of energy. And we have learnt about microscopic and macroscopic in the scopic topic. And it is the routinely applied analysis of atoms and nucleus. So it is routinely every day it is applied in the atoms, and the phenomena that occurs in whole universe all the times. In the all the universe, this phenomena occurs in all the time. And until the advent of Einstein's theory of relativity, the law of conservation mass was regarded the another basic conservation law of nature was made since the matter was thought to indestructible. It was principle used. For example, the analysis of chemical reaction to know what is happening in a chemical reaction. It is used, and a chemical reaction is basically rearranged of atoms. How atoms rearranged in chemical reaction and in exothermic reaction, and in many chemical reaction how it happens. They are tried to telling. And however, since the merely rearranged but not, we can rearrange the atom, but we cannot destroy the atom. Conservation of mass, where you are learnt in your lower classes. And the charges are too small according to Einstein theory. So according to Einstein theory, as you know, mass m is equivalent to energy E. Energy we call, and mass m is given the relation of E is equal to mc2, the Einstein theory, and mc is the speed of light. C is the speed of light in the vacuum. The Einstein is saying this about. So this expression you keep in your mind. This is like general knowledge. I can ask in your exam. And also this energy which is released in nuclear power generation and nuclear exploitation, and that also we use and conserve for we use it. And energy in scalar quantity and vector energy in scalar quantity, but all conserved quantity are not necessarily scalars. Means all the energy that we conserve, it should be not necessary that it is a scalar quantity. The total linear moment of total angular moment often isolated, both scalar or vector. It can be. The scalar means that has the magnitude, but it does not have the direction. In the vector, it has only magnitude, no direction it means. But here it has magnitude and direction. In scalar means magnitude, the magnitude, as you know, and the direction it has. But in vector, it does not have direction, only it has magnitude. And the law of conservation of mechanisms, but their validity goes beyond the mechanics. As you know, mechanics who want to take mechanics in their higher studies. And they are basic conservation law of nature. The basic conservation law of nature we learn, and many more laws here we are learning. The dynamic, thermodynamic laws, collision laws, and conservation law is an important tool. As you know, conservation is most important. Conservation of trees for the future, conservation of the nature for the future, and conservation of the whole world for the future is most important for whole world. And conservation law has deep connection with symmetric nature. It has deep conservation has deep connection with nature. As I said, we have to conserve the nature, so it has deep connection with the nature. And we also do experiment in laboratory, and as well as more experiments for observation, how to conserve and how to save it, and how to conserve the energy, or how to save the nature, how to save the universe. Laws of nature are the same everywhere in the universe. The laws of nature law is everywhere in the universe, and phenomena may differ from place to place because different places, different condition, and different location. Phenomena may be different, but law of nature is only one. And the acceleration due to gravitation in the moon is 1/6 the earth, but the law of gravitation is the same both on moon or on earth. The Isaac Newton is saying, and this symmetry of the laws of nature with respect to translation in the conservation of linear moment. In the conservation of linear moment also it is used. In the same isotope space, the conservation of laws of charges and other attributes of elementary particles can also be related to certain abstract symmetries, and symmetries of space, time, and other abstract symmetries play a central role in the conservation of fundamental forces. The fundamental forces that I said, the nuclear force, strong nuclear force, gravitational force, they are the fundamental forces in conservation of that for the nature. These things is necessary, they are saying. So this was your chapter physical world. Here they have given some exercise from, they are asking some questions. So I write answer for your question. And this was your chapter, the physical world. So okay friends, I think you have understand this chapter. This is the basic concepts they are saying about the fundamental forces that are the gravitational force, strong nuclear force, weak nuclear force, and the electromagnetic force or electromagnetic force that I have understood now. So okay friends, till then comment on my video, subscribe my channel, and then go to center for more video like this where I will finish and share my videos to your friends so that they may also understand. Okay friends, I will explain the next chapter of the 11th standard. So till then, take care, have a nice day friends. Bye.